Howdy. Powerful gamma ray burst made currents flow in the Earth. Astronomers have never seen anything like it. On October 9th, 2022, Earth orbiting satellites detected the strongest gamma ray burst, GRB, in modern history. GRB 221009A. How strong was it? It caused electrical currents to flow through the surface of our planet. Dr. Andrew Klekochuk in Tasmania recorded the effect using an Earth probe antenna. Here you can see the spike. Note STIX data have been flipped, increasing counts go down to ease comparison of the two waveforms. The blue curve is a signal from Klekochuk's antenna, which was sensing VLF's, very low frequency currents, in the soil at the time of the blast. The orange curve shows the gamma ray burst recorded by STIX telescope in Europe's Solar Orbiter spacecraft, one of many spacecraft that detected the event. The waveforms are nearly a perfect match. I'm a climate scientist at the Australian Antarctic Division. That's my job, says Klekochuk. VLF is my hobby. I started doing VLF radio measurements in 1970s when I was in high school. This is the first time I have detected a gamma ray burst. Klekochuk's unusual hammering uses Earth itself as a giant antenna. In his back garden, there are two metal spikes stuck into the ground 75 meters apart. They are connected to a receiver via buried wires. In recent years, amateur radio operators have been experimenting with this weird kind of antenna to detect VLF radio signals circling our planet in the Earth's ionosphere waveguide. Earth's crust forms one of the waveguide's walls, allowing Earth probe antennas to detect distant transmitters. During the gamma ray burst, I detected flickering from multiple stations, says Klekochuk, who made this map showing transmission paths illuminated by the GRB. Researchers have known since 1983 that gamma ray bursts can ionize Earth's atmosphere and thus disturb the Great Waveguide. This appears to be the first time anyone has recorded the effect using an Earth probe antenna. The outburst on October 9th shocked astronomers. Consider this tweet from Phil Evans of the University of Leicester. It's bright, really bright, like stupidly really bright. Evans works with data from NASA's Swift Gamma Ray Observatory, and the overflowing signal had apparently broken some of his plotting software. Data from NASA spacecraft have since pinpointed the burst. It came from a dusty galaxy 2.4 billion light years away, almost certainly triggered by a supernova explosion giving birth to a black hole. This is actually the closest GRB ever recorded, thus accounting for its extreme intensity. There are no black holes. Still, never will be. In our research group, we've been referring to this burst as the boat, or brightest of all time, says Gillian Rastenijad, an astronomer at Northwestern University who has been monitoring the burst's afterglow using the Gemini South telescope in Chile. When you look at the thousands of bursts gamma ray telescopes have been detecting since the 1990s, this one really stands apart. Meanwhile, other observers in the UK and Germany have also reported ionospheric disturbances from the burst. They all used regular above-ground antennas. 2.4 billion light years away, now that's a DXing. Where is this tweet? I want to see this tweet. Phil Evans. Swift detected the GRB yesterday. It's bright, really bright, like stupidly really bright. It turns out my analysis codes weren't really built for this thing, for things this bright. Yeah, I cannot use. I don't know what's going on here. What's that? Burst analyzer, position spectrum image. There are data for this object on the quick look side. This may indicate that we are still observing this object. This light curve is thus not yet final. But where is it? Anyway. Obviously. Once again, scientists are surprised or even shocked of what the universe can do. There is so much energy out there that humans really cannot comprehend it. And if you're living in a gravity-based paradigm, the amount of surprises and shocking experience and whatever stuff is going on there, you will continue to be surprised and shocked. This is how far away? 2.6 billion light years. What? 2.4 billion light years away, and it induced electric currents into Earth's crust. This should make many of those people who are working with these kinds of things, they're scientists, it should make them think about the role of electricity in the universe, the role of electricity in life. And how much it could do if there would be more of it. How much more important it is than gravity. Yeah, that's a burst. The afterglow, about an hour after it was first detected. This could be also a recurrent micronova, whatever novas are many. When you look at the thousands of bursts gamma ray telescopes have been detecting since 1990s, this one really stands apart. Thousands they have observed, but this one stands out. That's a thing. But anyway, I leave it here. Thanks.